Okay, hope I'm audible. I'm sharing my screen. So once it is visible, say yes in chat box. Anybody confirm, please? Is it? Keep it. Okay. Thank you. Thank you so much. Yeah. So before the break, we covered the chemical hazards. Now we try to see the physical hazards. When we say physical hazards, so the physical hazards will be noise, vibration, heat, cold, pressure, ventilation, and also air changes, air velocity, humidity, light, colors, excessive weight, overtime work, physical work, and also radiation. Again, in radiation we have ionizing radiation, non-ionizing radiations. So in the ionizing radiations, alpha, beta, gamma, X-rays, and the non-ionizing VR, IR, microwave, or laser beams. These are the uh, physical hazards. Sorry, we are jumping to the next screen. Uh, Let me wait. I'll. Okay. These are the ionizing and non-ionizing hazards. Then comes to the other side. Just a second, please. Then instrumental, which is no proper instrument, no control instruments or faulty instruments, no interlocks, no alarms, no trips, no auto controls, or no process corrections. These are also another hazards. Again, we have with respect to mechanical in the same physical, unguarded machineries, no fencing, no safety devices, no control devices, unsafe machine, equipment, and instruments. Then, with respect to electrical, no earthing, short circuit, faulty design, a current leakage, open wires, no fuse cuts or off devices, static electricity, or non-flame proof fittings, etc. Then in the biological, we'll have bacteria, virus, fungi, parasites, or plant pest, microorganisms, infections, and diseases. And with respect to ergonomics, this is also one of the physical hazard we can consider. Uh, those are wrong design or the wrong layout of machineries, poor housekeeping, and no man job alignment. Man job alignment in the sense the job is not fitted to the employees. An improper design and height or position of the controls, wrong tools or acquired positions. And apart from this, there may be an unclassified hazards also. Then these are the environment as of now with respect to chemical and physical. Maybe these are not limited, So there may be a few more hazards apart from this. Okay. And with respect to non-environment, so psychological will be there, tender age, old age, or tender age in the sense children's, old age people, male, female, ill health, sickness, no physical fitness, nervous strains, or fatigue. And psychological, employee side, wrong attitude, aptitude, no motivation or demotivation, job habits, smoking, alcoholism, emotional upset, unskilled, poor discipline, absenteeism, accident, proportions, no job security, no job satisfaction or leadership. In the employer side, no education, information or training systems for the workers. So if you see, these are the so many hazards which are associated with the workers, which will adversely affect the human health. Okay. Just a second. Okay. Then now we'll see the dangerous properties of chemical. We talking about the chemicals are the primary ones where it is badly affecting the human health. Now we'll see some of the dangerous properties of the chemicals and also their health effects. So when we see the dangerous properties, definitely immediately we can remember the MSDS, material safety data sheet, which talks about the material hazards and also its interpretation. When we say interpretation, it is understanding of the people, how people understand different wordings or different sentences. Maybe people read in a different way. Okay. Then if you see the properties mentioned in MSDS or dangerous properties, needing attention for safety, schedule 9 of MSIC rules 1989 and also statutorily require this information. So as I mentioned, MHIC rules, so after the Bhopal accident, the Indian government has recognized and they brought up these kind of rules to control the MAH installations, major hazard accident installations, to avoid any disasters or catastrophic accidents. In that, one of the rule is in schedule number 9 in MSIC rules, we have to submit or we have to generate MSDS for whatever the chemicals which you are manufacturing. So it is the occupier responsibility. When we say the occupier of the factory has to keep this information ready to know to the workers on request. So whenever you are working in a factory, you should definitely have this MSDS in place. It is not about the manufacturers, even though the users also should be provide such MSDS to their employees so that they will get in a familiarity with the hazards with respect to the chemicals which they are handling. సో ఇదేంటంటే ఎప్పుడైతే మనము కెమికల్స్ యూస్ చేస్తున్నామో మ్యానుఫ్యాక్చరర్స్ అనేవాళ్ళు వాళ్ళు ఎంఎస్డిఎస్ అనేది తయారు చేస్తారు, తయారు చేసి వాళ్ళ సప్లయర్స్కి అనేది ఇస్తూ ఉంటారు. సో సప్లయర్ అనేవాడు వాళ్ళు ఏవైతే కెమికల్స్ యూజ్ చేస్తున్నారో ఆ వర్కర్స్కి ఆ ఎంఎస్డిఎస్ మీద అవగాహన కల్పించాలి. సో బికాస్ ఇఫ్ యూ సీ ఇన్ ద మోస్ట్ ఆఫ్ ద ఇండస్ట్రీస్ ఆర్ it is not practically possible to have all educated workers in the shop floor. So we used to have so many uneducated workers. So it is always better to have pictorial representation of the MSDS, so that, or visual representation, pictorial or visual representation, so that they can easily understand the properties of the material. So if you are explained by the pictorial representation, it is easy. So for some common chemicals and their health effects and the occupational disease, now we'll see some of the common health effects. One is classification of airborne contaminants. So when we say airborne contaminants, when a chemicals are disseminated in air and contaminate it, they called airborne contaminants, which means అవి గాల్లో కలిసిపోవటం. It is mixed with the a natural atmosphere and which is contaminated the air. Those called as airborne contaminants. They are classified according to their physical state, which are gases and vapors. When we say airborne contaminants, there are in multiple types, which are majorly gases. So gas is nothing but normally a formless fluid which occupy the space of enclosure and which can be changed to the liquid or solid state only by combination or combined effect of increased pressure and temperature. The gases diffuses and particular size varies from 0.005 to 0.01 microns. So initially it is in a formless fluid. If you are having any external pressures or atmosphere, it can turn to liquid or solids. If you see examples of chlorine, ammonia, sulfur dioxide, hydrogen sulfide, even hydrogen cyanide, carbon monoxide, etc. will be there. Then when we say vapors, so vapors are, these are the gases in the form of substances which are normally in solid or liquid state and which can be changed to these states by either increasing the pressure or decreasing of the temperature alone. So sometimes maybe increasing the pressure or sometimes decreasing of temperature also, it can change their state. So vapors diffuses, the particular size of vapor will be, again it is similar to 0.05 to 0.01 microns. When we see examples of vapors are benzene, xylene, trichloroethylene, and other solvents. Those are vapors. And next is particulate matters. So most of the people are well familiar with this who are working in manufacturing sectors. There are two types of particulate matters. One is PM 2.5 and PM 10. These are the two different types. These are in solid tiny particles like dust particles, which is produced by blasting activity or crushing activity, drilling, grinding, mixing, etc., and suspended in the air. Suspended in the sense it is been there for some time in the atmosphere. Over after some time it may settle down, but depend on the circumstances. Sometimes it may not settle down, or sometimes it may settle down. So when I say PM 2.5, these are fine particles than PM 10. When I say 2.5, it is the size of uh, the air particles. Okay. When I say PM10, it is also size of the particle, 10 microns or 2.5 micron. So if you say 2.5, the examples will be the vehicle emissions or industrial emissions, tobacco smoke, burning of candles or any incense or emissions from the office equipments. When we say PM10, it is from the construction sites or pollen from the plants, mold spores or smoke from the wildfires or bacteria, which is the size is bigger than 2.5. Okay. So other one is dust, other airborne contaminants. So you will see physically these dust particles. Some of the dust particles we could see visibly in the heavy wind situations.
As of now, industry is giving every factory to install RECD for 600 kVA engine for reducing the particulate matters.
Yeah, for the DG sets, right?
Right, this is it, right?
Yeah, yeah, that is true.
For same purpose, for reducing the PM.
Yeah, PM, yes. Yeah. Then other airborne contaminants is solid particles which are generated from again handling, crushing, grinding, and rapid impact or detonation and uh, disciplination of organic or inorganic materials such as rocks or ore, metals, coal, wood, grains, etc. And thus do not tend to flocculate except under electrostatic forces. They do not diffuse into the air but settle under the influence of gravity. Because of the gravity of the particles, they tends to settle in the certain levels in the atmosphere. The particulate sizes of varies from zero point 0.1 to 1000 microns. The fly ash from the chimneys varies from 3 to 80 microns. So here is the one ideal picture. So to differentiate from gases to the grit level, when we say grit, it is an example of grit blasting. There they use different types of grit for the blasting purposes. It is nothing but a solid visible particle. So if you see gases which are very thin or in nature, so the particle diameter it is in microns. So 0.0001, which is very small, and the other end we have 10,000 microns, which is a visible dust particle or a dust. So very fine dust or a fume. If you see in between, we have fumes or fine dust or chorus dust, which means it is visibly seen. So in this, if you see 0.012, it is an atmospheric dust to up to 50 micron. Then from 0.01, we'll say welding fumes and dust, which is up to 1500. I'm sorry, there is too much background noise. Yeah. Then we have tobacco smoke, which is in between zero point zero 0.01 to 5 micron in between. Then coal dust we have zero point 0.1 to 15, and again cement dust we have from zero point 0.5 to 15. Then a pollen or other grits. Okay. Even if you can Google it, the specific material, you can definitely get the size of that specific airborne contaminant. Then fumes. So when we say the fumes, again, these are solid particles generated by the condensation from the gaseous state. So generally after the volatilization from the molten metals, etc., and often accompanied by the chemical reaction such as oxidation process. The fumes are fluctuates and also sometimes the coils. The fluctuation is nothing but again ETP operations. How you see, then the particle size will be again 0.0012 100 microns. Example will be lead, zinc, and also nitrous fumes. Then we have mist again. It is also suspended liquid droplets generated by again condensation from the gases to the liquid state or by breaking up in a liquid into the dispersed state. When we say mist, you will say, especially in the winter seasons, you will see this mist. Then these are by the splashing or foaming or atomizing. The particle sizes varies from 50 to 100 microns. Example would be sulfur acid mist. Even the mist can be generated for in the automobile washing centers. Fine liquid droplets for cleaning of vehicles. Then smoke or gas borne particles resulting from incomplete combustion and consisting predominantly of carbon gases materials or grouped in this category. A particle sizes varies from zero point 0.1 to 1 micron. So these are different in types. Again, smog and fog. We know smog. Anybody knows about smog?
Sir, పొగమంచు.
Okay. What is the between then fog? Smog. It is basically it is in a type of air pollution which is happens because of the emissions which are coming from the vehicles. Basically, these are nitrous oxides and VOCs. Then it forms a dense layer in the atmosphere. That is a smog. Even sometimes we used to see in the news also there is a smog effect in Delhi in some regions. Then fog. It is again it is air contaminant best presence. It is a kind of again same effect, but it is not a pollution. Especially in the winters we used to see it is in a natural weather. It is a kind of a water vapor. That is fog. Okay. Again, this particle size also it is varies from 1 to 50 microns in size. Then aerosols, it is called as a colloidal system, uh, which the dispersion medium is gas and also dispersed phase is a solid or liquid. The term aerosol is applicable till the solids or liquids remain suspended in the gaseous media. So whatever the solids or liquids which are suspended in the gaseous medium, we called as aerosols. All our spray cans, even paints or the your perfumes, all will fall under these aerosols. Here, the particle size will be zero point 0.1 to 100 microns. Dust, smoke, or mist also some of the examples for this. Okay. Now we'll see the routes of entry of the chemicals and also their effects on our human body. So there are different routes a chemical can enter into our body. So one is absorption through the skin. The skin absorption attains its greatest importance in the connection with the organic solvents, and the significant quantities of these components may enter into the body through the skin either as a result of a direct accidental contamination or indirectly when a material has been spilled on the clothing. So this is how our skin have an absorption mechanism. Due to that absorption process, if you are exposed to any of the chemical accidentally or directly or indirectly, the chemical can enter into your body. Using industrial solvents for removing greases and dirt from the hands and also arms in the source of dermatitis. So what will happen if you're using any grease, or sometimes the people used to take the diesel to take out any contamination, or sometimes they used to have other solvents for the cleaning of their hands. So it will also have high chance to enter into your bloodstream. It can create dermatitis. It is a kind of skin related disease or skin related issues. Some of these solvents penetrate the intact skin, get into the bloodstream and produce ill effects on the blood and throughout the body. Example: nitrobenzene, aniline, phenol, nicotines. These are can also interact with the bloodstreams and blood. It can generate overall ill effect on your body. And while manufacturing, handling, and spraying pesticides, if you see spraying pesticides, also it is very important. You see, most of the farmers, they won't have any PPs. They won't use any uh, full body suits or coverall or any gloves, nose mask or gumboots or etc etc. Even they mix the chemical with their own bare hands. When you say bare hands, direct hand, there is no protection. That is also very important. We have to educate our own people, because most of the people from the farming background, if they you're not from the farming background, if some farmers are doing such kind of uh, activities, you can educate them about the hazards associated with this chemicals. Okay. Even liquid splashes may enter through the skin and causes toxic effects. Vapors of pesticides can enter through nose, and solid or liquid pesticides if may taken through mouth. So the vapors of pesticides, when we say vapor, you can, while doing inhalation process in our natural process, in breathing process, it may enter into our body. In other case, if there are solids like fertilizers and all, it may enter through a mouth. Unknowingly or accidentally or suicidal effects. Sometimes if you're attempting for a suicide also, these chemicals may enter into your body. It can pass through digestive routes also. Sometimes what will wear whatever it is going through the mouth, definitely it will go through your digestive system. That is where, in case of anybody swallowed any corrosive chemicals, it is not advisable to ask them to vomit, because what will happen while taking the chemical, it will uh, while going through the stomach, it will damage your complete system. Again, if you are trying to vomit it back, again it will uh, give another damage while coming out of your stomach. So in case of such incidents, if you come across, we try to neutralize the chemical, or you try to neutralize the concentration of the chemical. Okay. The volatile materials like phenol, aniline, and also nitrobenzene, creosol, tetraethylene, lead, and also many of the argon, phosphorus, or any argon, chlorine pesticides pose greater hazard through the skin than the through the inhalations. It gives more hazard through the skin and also inhalation. Then inhalation, even though inhalation is there, but the more effect you will have through the skin only. And absorption through the lessings or vitaminis is more rapid than the through the intact skin. Cut skins may absorb quickly, therefore safety gloves, aprons, face shields, goggles, and overalls are always desirables. Okay. Cut skins. So when we say cut skins, or the injured part or the wounds are the primary sources of entering a chemical into your body, because it is an easy path, because somehow our skin will try to resist, but injuries or wounds are, it is an easy path of the chemical can enter into our body. Then absorption through the stomach tract, it is nothing but ingestion or a digestive tract. So use of contaminated and also dirty vessels used for eating or drinking is the most common route of an ingestion. So contaminated foods or contaminated vessels or containers you are using for having food or drinking water, etc. Even accidental swallowing of chemicals is also possible, and the detoxification affects the liver experts when the ingested quantity is small. However, massive dose can lead to a fatalities in the absence of medical attention. So, whenever you have consumed any toxic chemicals, our liver will try to fight against those toxins to some extent. If it is beyond that limit, you are facing a further health issues. If you are consuming more than the limit of the liver, so definitely you will be died if you didn't get medical attention on time. Again, the contaminated food, drinks, and beverages should not be eaten without washing the hands and mouth properly. Habit of washing hands and mouth before and after eating is most desirable. Where it is statutorily required, a separate mess rooms, eating places are provided for these purposes only. Food, drinks, and pan, safari, tobacco, lime, etc., and smoking are prohibited in the workrooms. Wherever you have a chemical operations, there where you will have dedicated workrooms or canteens for food consumption. That's where even they used to see in the during the, in the workplace, the eating is prohibited. Eating and drinking is prohibited. Even I have seen one of the company where they produce lead acid batteries. So they won't allow their workers to eat with their hands. They always have the food within the company by using the spoons, so that they can avoid the lead contamination. Even after the shift, they'll have a shower, complete shower. Then only they will go to home, and they will change to their personal clothing from the work clothing. Then they leave the company. So that is how the companies are taking the controls to avoid the contamination. Okay. For now, I'm stopping here. We have only 24 seconds. We'll continue in the next class. Any questions?